Hi guys, Mrs. H here. Today we're going to be looking at the ions on our ions and isotopes notes. So when we're looking at ions, we really have to understand the octet rule. So when we look at noble gases they don't react with any other element. And the reason why they don't react with any other element is because of their electron configuration, which basically means how their electrons are in that energy level and in that cloud. So let's look at argon here. So if we look at argon, remember argon has 3 energy levels, and we know that because it's in the third row or in the third period. And it also has 8 valence electrons. And remember, valence electrons are electrons in the outer energy level. And how we determine that is what row it's in, or what column it's in. And so if we look at our Bohr model and we look at our Lewis dot structure, we see these 8 electrons and these 8 electrons. And this configuration is a really good energy efficient arrangement. And so because of that, these atoms don't react because they like this. This is good for them. Now, atoms that don't have this octet rule, octet rule, will actually incorporate electrons into their energy level or get rid of electrons in their energy level to satisfy this outer energy level being full so that they would resemble the noble gas electron configuration. And this is why compounds are formed, is because atoms are trying to get this electron arrangement. And so metals tend to lose electrons to achieve this configuration, and nonmetals will actually gain electrons. And so that's how we will look at ions, and that's how ions are formed because atoms are trying to establish this octet rule. So let's look at what an ion is. So an ion is actually a charged atom. And so how does an atom become charged? Well, we have to have an imbalance of protons and electrons, because remember, protons are positive and electrons are negative. And so remember, in an atom, we have equal amounts. So if I have 5 protons and I have 5 electrons, they cancel each other out and they're neutral. But if I start losing those electrons, or gaining those electrons, I'm not going to have an equal amount to cancel each other out. And so I'm going to be charged. And so this is kind of tricky, but we got to really think about this. If I gain an electron, I'm actually gaining a negative charge. And so I will become an anion. Because gaining, I know gaining, we think positive. No, we're gaining a negative charge. So we become negative. So it's an anion. Now, if I lose a negative charge, then I'm going to become a positive because I now have more positives than I have negatives. So let's look at this example of I have 5 and 5, right? So this 5 and 5 arrangement would be boron. So boron has 5 protons and 5 electrons, and they cancel out. And so neutral charge. So let's say I have 5 protons, right? But I lose, okay, I have my electrons, and I'm going to lose 2, right? What will happen? So here I have 3 electrons and 5. So what happens? I end up with 2 extra or 2 positive protons. So I end up with a positive charge. On the flip side of that, let's say I only have 3 electrons and 3 protons, but I gain 2. So what now? I have 2 more negative charges, and so I have a negative charge particle. And so this is how ions work. And we indicate ions with this little charge symbol over here. So if this, and I don't know why there's an F there, I'm sorry, that should be, or an FL, that should just be F. If I gain a negative charge, I gain an electron, I'm going to have, like fluorine here, it would be -1. But on sodium, on the other side of the periodic table, it will lose or lost an electron, so it would be positive charge, and we put these up in a superscript position. And we saw that on the PhET build an atom model. So let's look at what's going on in those Bohr models. So here I have an atom of oxygen. And so remember, oxygen has a total of 8 electrons, but 6 valence electrons. So I have these 2 holes here that they want to fill with electrons. So oxygen atom is actually going to gain 2 electrons. And so it had 8 protons, and now it has 10 electrons. So if you notice, there's two extra negative charges. So oxygen will become a -2 or a -2 anion. If we look at this in the Lewis dot structure, so again, remember, oxygen had 6 valence electrons. We just added 2. So this is what the Lewis dot structure would look like. So again, thinking about the octet rule, atoms want to have 8 valence electrons, so it's going to gain or lose electrons. It can't gain or lose protons because then we're changing an atom. So if this oxygen lost 1 atom, it's no longer oxygen, okay? So what is being lost is the electron, or what is being gained is the electron. And it's all because it wants to be like the noble gas. It wants to fulfill the octet rule and have 8 valence electrons on the Lewis dot structure or in that outer shell. So if you have any questions about ions, please make sure you're reaching out to me. Today we're going to be looking at making Lewis dot structures like you see here for atoms and ions and what this would look like. And now tomorrow we'll be moving on and looking at isotopes. Don't forget to reach out to me for help, and have a good day. Bye, guys.